Okay, so we're talking about exponential growth. This is your parent graph for exponential growth. Would you copy that down into your notes? You don't have to. Well, actually, pretty much everything up there is important, I guess. The y equals a bx is important. I'll tell you what each part means. This is the starting value. So if you started with $100,000 that your great Aunt Tilly gave you, this would be 100,000 right here then. And then you throw it into stocks and it goes up. Like Forrest Gump. Remember what company he bought? Some fruit company, he said. Apple. Yeah. And that was in the movie Forrest Gump. And little did they know that Apple would go on to grow to be about 10 times what it was even after it was mentioned in Forrest Gump. So the number here is called the base. And it tells you if it's growth, if it's like a number bigger than 1, or decay. And the fact that it's got an x in the exponent is how you know it's exponential. Things are exponential if they have an x in the exponent. The x isn't supposed to be down low, it's supposed to be up here in the exponent. If the x was down low, we've already done that kind. That's like a quadratic, that's like a cubic. If there's an x down low, that's nothing new. The new thing is that the x is up here and the number is in the base. Okay? So if the x is in the exponent, then it's exponential. All right, that's the new thing for today. But again, to get some of our basics down, when these exponents here are some weird numbers, we need to know what to do. And so, let's see if you know what to do. I know you know it's a plain old number, like 5 squared, you know that's 25. But what about 7 to the negative 2? It's not 49. What's 7 to the negative 2? It's not negative 49. That's the most common mistake answer. Thank you for trying, though. What do you think? 1 over 49 is correct. A lot of you have forgotten that little thing. When you have a negative in the exponent, you just take the answer you would have had, 49, and then you flip it. It's a reciprocal. How about if you have a fraction in the exponent, like 1/2? That means something really simple. Say it if you know it. Yes, sir. You are correct. Square root. So 16 and then that little thing up here means square root of. And so what's the answer? 4. Write these down. You need a few examples for yourself. You're going to go home and you're going to go, oh, I know 1/2 power means something, but I can't remember what. All right, I wouldn't be writing the f of x over and over and over again if I were you, but I'd be writing these little examples here. 49 to the 1/2 then. If you understood the last one, you should get this one. 7. Just means square root of. All right, here's a little trickier one. Do you get that it's sort of cubed, but it's sort of to the 1/2 power? It's actually both. If I broke that up, I would go like this. 4 to the 1/2 power to the 3rd. You get how that'd be the exact same thing? Because I would multiply this, and that would make it 3 over 2, right? So anytime you have one that's got two things happening in the exponent, you have to do both of them. So we got to take the square root. So what is this part right there? 2. And then I cube it. And so what's the answer? 8. We're going to do a few of these. Make sure you're good at them. All right, write this one down, please. 16 to the 3/2. First thing you do is write that down. Second thing you do, Grant, break it up for me. 2 parts. 16 to the what? And then to the, you got it. So RK, first part. And do you know what 4 cubed is? 4 times 4 is, and then times 4 again is 64. Raise your hand if you followed that. You get this. Okay, good. Then, the piece de resistance. Do that one. It's got all three parts. If you get all three things I just told you about exponents, then this part shouldn't be that bad. All right. You should have broken it into three things. This, and what's the last thing? A negative. I usually say -1. Okay, so there's three things going on. Mr. F, what's this part? And then this part? And then this part. You got it. Raise your hand if you had 1/8 on your paper. Okay, good. Then you very quickly have gone from not even knowing what square root meant to doing all three things. Okay, so this isn't that hard, but you got to be able to handle it when they have a negative up there and they have a fraction up there in the power. Was what I just did right there an exponential or not? Did it have an x in the exponent? No. But it could have started as an exponential by doing this, 4 to the x. And then I could have told you an x is -3/2. So then you'd go, oh, okay, so you really meant 4 to the -3/2. So all of a sudden it's not an exponential anymore because you put numbers in it. That's an exponential. That's not, because it's got only numbers. Got to have an x in the exponent. Okay, moving on. 3 squared, duh, 9. What's 3 to the -2? 1/9. Okay. How about that? Ooh. All it is meant to remind you that something like that is just something that's been moved. It's been flipped. And it's been moved to the left or right. It's been moved up, down, and it's been flipped. What's that mean? Right 4. What does that mean? Up 5. And is that an up-down flip or a left-right flip? Up-down. Stuff on the outside is up-down stuff. So both this and this are things on the outside, so they're up-down things. So that's an up-down flip. So this got flipped, reflected over the x-axis, is another way to say it. It got moved right 4, and it got moved up 5. You remember that? So now, what's that? Is it exponential? Because why? Because it's got a x in the exponent, and so it's an exponential that's been moved. Take a guess. Does that +1, do you think that means moves up 1, or do you think it moves left 1? Left 1. And then what do you think of that means? Down 6. All right. We're already 2 days into our material. That's like 2 days worth of stuff. So you're going to be fine. All right. Here's back to that original graph. Remember the parent one that I had you draw? Now this is some that are a little tighter. The bigger the base gets, the tighter it gets. It's like somebody grabbed it here and is pulling up. Okay, the blue one's the tightest one. So if I were to do, for instance, a green one, and were to say y equals 20 to the x, what do you think it would still go through? 0, 1. It would. And it would go really low here, and then it would go super steep right there. But it always goes through this spot. Let's explore y for a second. At that moment, what is x equal to? If x is 0, do you get that I'm putting something to the 0 power? What is something to the 0 power always equal to? That's why it's 1. Okay? Because I'm always putting in a 0 here. And so each of these turn into 1 at that spot. It always hits 1. Okay? And how bigger this number gets, the tighter it is. It's like it's being pulled, stretched tighter and tighter. All right, moving on. That's not exponential growth anymore. That's exponential decay. Do things like that happen in the real world too? Do stocks always go up, up, up? No, sometimes they decay and they go down. Sometimes it's because your rich aunt has got all the money she needs. She's got $10 million in the bank. She doesn't want to put it in stocks. She just wants to slowly draw it down and use it to, like, maybe it's to go on trips with or whatever, but she doesn't want to invest it and make it go up because she's scared she's going to lose it. So she just puts it in the bank, and she takes like 4% of it out every year. Okay, and then it just slowly goes down. Okay, if you only take out 4% every time, that would be exponential decay. If you took out $4,000 a month, that would be decay that would go in a straight line like this. But if you take out 4%, it would curve like this. That's the difference between taking out like $4,000 a month or taking out 4% of it each time. It would have a curve like this. Because by the end, you're not taking out as much because you don't have as much. At the beginning, if you take out 4% of $4 million, that'd be a lot of dough. Or 4% of $10 million. That's a lot. But if you only take out 4,000, that's much less. So it won't go down as fast. All right. Exponential decay happens in the real world too. This one's another important one, worthy of your notes. Please, right now, copy that one down. You'll notice I don't ask you to write everything down that I do. There are some things that are more important than others. I will try to note these moments when they are kind of important things. And I would, if I were you, put a star next to them in your notes. This is one of those moments. You need to know these three functions. One of them is the exponential we just talked about, e to the x. It's this blue one. Y equals e to the x. Now you might be saying, well, you used to have a number there. It used to be like y equals 2 to the x, and now all of a sudden you're changing it to an e. E is a number. You might know what it's worth about. Okay, you're going to learn something then. E is about 2.7. E is about 2.7. I'm going to put an about equal to sign. That's kind of like how pi is about 3.14. You know, because it actually goes on forever. Well, so does E. E is about 2.7, but it is actually this really cool math number, kind of like pi, that's important, and it's worthy of, like, we could spend 3 days understanding just E. But it's a number like about 2.7. So do you get how e to the x is pretty much just like 2.7 to the x? Because e is 2.7. So it's pretty much just like 2.7 to the x. So that's what's going on there. The reason e is so important is because it's the exact inverse of this guy. What's that one? Know the name of it? ln? What's the name of that? It's called log. If you can't see this from the back row, I will blow it up for you. Y equals ln of x. It's the natural log. I don't know if you've ever noticed that button on your calculator, but there's an ln button on your calculator. It stands for natural log. All right, so the red one and the blue one are inverses because they're an exact flip over the green line y equals x. These are 3 of the big 12 functions that you are supposed to learn that are in the back of your book. Do you remember that? In the back page of your book. You got a list here of the top 12 pre-calc functions. It's not just for our school. I mean, this, you got to know this book was printed for the whole United States, right? So these are probably the 12 most important pre-calc functions. And I've seen them, I've gone to math conferences and stuff, and they always reference the 12 big functions. These are the 12. Okay, these are 3 of the 12. These are the 3 we're talking about right now. Okay, so these are worth your attention. These are kind of important ones. Okay. So they're inverses because if I flip this guy, I'm going to try to draw it really close. Okay, I was off a little bit, but I was pretty close. If I take this thing and I do a flip left, right, that doesn't match up. What do you think I could do to it now to get it to match up? Another flip. Up, down this time. And now it matches up. See? So it's an inverse. It's a double flip. Okay, that's what inverses do. Another way to say inverse is that every x becomes the y. It was at 0, 1. Now it's at 1, 0. See, they flipped around. There was a spot here at 1, 3, And now there's a spot at 3 comma 1. See what I'm saying? They're inverses. That's really important that you get this concept. All right, moving on. This is a derivative, and I realize it's probably way over your head, but for those of you that think that you're probably ahead of the average kid in here, maybe you can understand this. A derivative is something that you're going to learn in calc, and the derivative on this y equals e to the x, a derivative is a slope of a line. How would I say the slope of this blue line? You can't really tell me its slope because the slope's changing all the time. It's getting steeper and steeper, right? So what you do on a curved line is you tell the slope at a given point. That point right there, then I can tell you what the slope is at that moment. You draw a straight line through it. It's called tangent line. And then that tells you the slope. The e function is the only function where this y value is exactly the same as its derivative. Now that's something that a math teacher would appreciate, and you probably don't, but I'm trying to tell you why e is so special, because that's the only number in the world where the derivative at that point will be the y value of it. So if nothing else, maybe you got an idea of a calc term that you're going to learn, the derivative, and you're going to see that next year. Okay. So what happens when we do this? Do you remember that this was the starting value? So what do you think we're starting at? 1. And do you see that this is a decimal and therefore not going to make it grow? This is going to go down from 1, isn't it? So it's like starting with 1, let's say $1,000. And then I'm going to have less. I'm going to have $870 after the first cycle. So this is telling me the base, and this is the starting value. And that just tells me that it's exponential. And that's going to be however many cycles that it takes. All right. I want you to write me something just like that, except for this. We start with, this actually happened in Florida, 2 snails. Then the snails have an insane growth rate. 2 snails get together, they'll have 1,000 baby snails. Okay? So we're going to say that the base, or the growth rate on this thing, is 1,000. We have an equation for it. All right, so you got f of x, so some function. That just, I didn't tell you what to put for that. I told you to start, though, with 2 snails. And growth rate of 1,000. And then, how do I make it an exponential? Put an x in the exponent. There we go. That happened in Florida, and they had such an outbreak that they spent over $1 million to try to eradicate these snails. And it just happened because some guy had 2 pet snails, and he let them out into the wild because he couldn't bear to, like, you know, kill them, and he was kind of sick of them, so he let them go. And they went crazy in his backyard in Florida, and all of a sudden there were snails spreading across the whole state of Florida, and they narrowed it down to like sort of like an infestation problem, and they figured out that's where it all happened, in this guy's backyard. And then they figured out that this guy had brought these snails over from, I don't know, some foreign country. He got in some trouble, yes, but you know, they really couldn't expect him to know that his snails were going to explode in population and cover the whole state, but it was just his 2 snails. And then they spent bazillions of dollars eradicating them, and then somebody else just did it in Florida again. So now they are starting the process again. At least they know now how to kill them really fast, and so, but they've got this snail infestation again, and they got to wipe them out because otherwise they spread so fast. Think about this: there'd be snails like everywhere down there, and it'd be pretty disgusting. Okay. So if I gave you that, you would know 2 things. You would know what? Starting value, which was what? 3. And is this growth or decay? It's growth. All right. How about that guy? Started at growth of, and that's also known as the base. The base is 2. How about that one? Is that growth or decay? That's decay. All right. Now let me ask you this. Is it 75% decay? Think about that. What percent decay? 25% decay. Because see, when I multiply by 0.75, it takes my dollar and turns into 75 cents. That means I lost 25 cents. Okay, so it's 25% decay. All right, moving on. What's the difference between this and this? Only that there's a 2 up in the exponent. That's a lot like moving it to the right 2, or moving it down 2, or what is this though? It takes the graph, stretches it which way? Left, right, or up, down? The stuff in here by the X is the left, right stuff. Yep, so it's left, right. Is it actually twice as wide then? No, I can't trust those, so it's actually half as wide. All right. This one, compared to the parent one, this guy has been flipped which way? Left, right, or up, down? The stuff on the inside here is left, right. That's a left, right flip. The stuff on the outside, be it in the front or at the end, is the up, down stuff, and that's been moved down 4. So it's a left, right flip and down 4. Okay, again, I'm covering like 2 days of stuff here. The first section of your homework looks kind of like this. Let's make sure you're actually ready, because I really want to try to cover everything that you're supposed to know so that when you go home on your homework that you're not confused by it. On the other side, I do expect you to do your homework. So when you come back tomorrow, your homework needs to be done. I'm going to have you hand it to the person that I tell you to, either be in front of you or behind you. We're going to grade them. We're going to take the scores. We're going to put them right into Skyward, and they count. They're not like in the no count. This counts. Counts on your grade almost every day. Okay, so get your homework done. Is that too much to ask? No, especially when the answers are out there. You know that. The answers are printed. You can go home and hit print and have all the answers for the next, like, month. Okay, so you don't tell me you couldn't have 100% on this. So I strongly encourage you, those of you that are new to me, make sure you get your homework done, because it'll count and it'll make a big difference in your grade after a while. The other thing is, as I looked across grades, for my kids, I had 12 kids that were on the borderline of the next grade up, and like they just missed it, and I bumped 6 of them. And the other 6 didn't. Is it based on me liking the kid or not? Nope. Some of the kids I really liked, but they were slackers. Hadn't done their homework, so I'm not giving them a break. If you try really hard, there should be a reward for that. Okay, so get your homework done, and then when there's moments like that, when it's like, should I give it to him? Yeah, he's trying really hard. I'll give it to him. There's moments like that when I'm grading tests too. Okay, so I just encourage you to show me that you're trying hard. And the way you show me you're trying hard is by doing your homework every day. That doesn't mean if you skip a homework assignment once, I've written you off. No, it's if you keep skipping them over and over again. Some days you'd just be too busy, I understand. It should be rare though. Okay, so here's your homework problem. Is this exponential? Well, does it have an x in the exponent? So yeah, it's exponential. And what's the starting value? And what's the base? Should be easy on that one. Is this exponential? What's the starting value? It's a little tricky though. 1. It's the number in front of this. And then what's the base? 2. And is this exponential? No, it's not, because it doesn't have an x in the exponent. All right, how about this is another trick one. X to the 5th. It seems like it's exponential because it's got an exponent thing going on, but that's not exponential. Why? Because the x isn't in the exponent. Here's another thing. What if it was an a to the x? Is that exponential? Technically, it's not, because it needs a number for the base, 2. It can't have a, this is like having an x down here and an x up here. See what I mean? All right, so my snappy little saying of having an x in the exponent works, but if it's got like this, that's kind of one place where it would fail, because that would not be exponential. Even though it has an x in the exponent, it's also got an x for the base, and that's not okay. This is not exponential. All right, the next section on the homework looks kind of like this. Compute the exact value of the function. All right, so x is -2, so I'm going to put -2 right there. And you'll know to take the 4 to the -2. And before you walked in today, you would not have known what to do. But I hope you know now. You take the 4 and you square it, and then what's that negative mean? You flip it. So it turns from 4 squared, which is 16, into 1/16. So this would be 3 times 1/16. All right, this one. I'm going to put right there, I'm going to put that, and I'm going to blow it up. 8 times 4 to the negative 3/2. That means 8 times 4, and it's got 3 parts. First you make it smaller, then you make it bigger, then you flip it in your head. What's that? 2. 2 cubed. 8. 1 over it. 1 over 8. Times it by 8. 8 times the 1 over 8. Final answer? 1. Uno. Okay? All right, so hopefully fraction exponents are not going to scare you as much as they would have. All right, your homework is right here. It's on the board. I'll write it up here. Page 286. I know some of you don't have your books today. You're going to need to borrow one from me. If you want to borrow one from me, leave a shoe or a cell phone. Only those 2 things if you want to borrow my book. Reason? Sometimes kids by accident, bell rings and they're like, oh, time to go, and they grab my book and they leave. They're $100. So please leave me a shoe or a cell phone if you want to borrow one of those books. I have quite a few over there, of course. If you don't have a book, we have this chapter saved on Schoology under Files and Links. Okay, so if you go under Schoology, Files and Links, the book is there. This chapter of the book is there, and it's behind a password. It makes it legal for us to do that, and also because we have bought books for everybody. It's just that some of them still haven't arrived. I've been waiting like a month and a half. It's very frustrating. Okay, get to work. This is not a talk time. You could talk while you're working, but you need to be working and then doing a little talking on the side.